Okay, so for the longest time, I've always said that a light year is 5.88 trillion miles, but for some reason, I've never really made a video actually kind of explaining, like, how do you visually represent that? Like, how do you imagine something like that compared to what we are used to? And I think the reason why is because I really couldn't find something that could accurately measure it. So I came up with something like closest to it. So I took like 50 miles an hour and I basically figured this out because, when you're driving in a car traveling, usually 50 miles an hour if you're not on the expressway is kind of pretty, it's either 50 or 55 miles an hour you're traveling. But let's say, like, in my area, it's usually 50 is what you're usually traveling. So if that's the case, let's try to figure this out. So if you were to take 5.88 trillion miles, now keep in mind 1 mile is 5,280 feet, but we're going to keep it in miles in this video, and you were divided by 50. So 5.88 trillion divided by 50. You would get something like, I think it's 117 billion 600 million, and then you'd have all the zeros after it. Then you would take that number divided by 24 because there's 24 hours in a day. And so basically you would have 4,900,000,000 days you would have to be driving consecutively for 24 hours. 400, no, 4.9 billion. So 4,900,000,000 days you would be driving at 50 miles an hour, not making any stops, or if you did make any stops, when you would have to resume your trip, is how many days it would take you to equivalently drive until you hit that long. But I know some people would say that's probably a bad example because you're not really, so you would equal 1 light year basically. But that's how big again, that's how big some of the units are in space. Our, like, even our solar system isn't even close to 1 light year, and yet it's still huge. And yet they say that our galaxy is like 1.9 million light years in diameter. And try wrapping your head around that. So 1 light year is that big, and then you times that by 1.9 million, or even it's even bigger than that because it's, how do you measure these big objects in space? But and then you got like objects that are even further away, and they might be even bigger because they're so far away. It's what is known as like the illusion of distance. And yet at the same time, it really should make you really think, hey, you know what? That's actually pretty large. But if you wanted to, instead of 50 miles an hour, you basically could round it up to any speed you want because you'd be traveling through space at, like, something ridiculous. Like, so basically take like 4.9 million, and if you wanted to, like, increase the speed, like, let's say it was 600, like, say you were realistically traveling at like what a plane can travel or something like that. I think it's like 600 miles an hour or something like that. It just basically times that by 12. So take 4.9 billion, and so again 4,900,000,000, and divide that by 12, and then whatever you get there, that's how many days consecutively you'd be driving, piloting on autopilot. But of course you'd be dead by then, before you'd reach 1 light year. But if somehow we could travel through space a whole lifetime, we could definitely get out of the solar system at some point. But we would probably be in the next one, and then whatever's over there, it's hard to say. But then you have like objects that are moving faster in space, and I mean, but at the same time you would have to be piloting something in space, and then you still couldn't see because light doesn't mix with dark matter. So how would you be able to see what's in front of you? And of course science fiction, if it actually made sense in this case, where you have like the solar shields and all that, you're hitting everything in space. What about the big giant asteroids and everything, like the asteroid belts, or even when you get to the Oort cloud, that stuff's frozen. So, and then you got comets that are flying around in there. You're talking like maybe 1.4 trillion or something absolutely crazy. Yeah, it's basically the further out you go in space, the bigger the circumference, orbits in this case, and there's more objects colliding with each other because they break off from like bigger objects and they end up being where they're at. So it's interesting to think about just how big space is, but it's also pretty scary too, even if it doesn't really affect our lives. But it is something to think about, though.